Hi everyone, I'm Youssef, CTO of Graiphic, and I'm truly happy to be here with you today. So today we will present you AI framework, a complete AI framework of total orchestration of ONNX on ONNX runtime. So we are proud to present you the first AI framework entirely developed around ONNX on ONNX runtime. So I will show you something new. Let's start. So let's start with something everyone here is familiar with, the AI landscape. So what you are looking at, what I'm showing to you here, is AI is a flow, standard flow of AI today's ecosystem. So we develop models with leading AI frameworks, Keras, TensorFlow, PyTorch. Then we convert them into ONNX system file. And when it's done, ONNX ecosystem take over, and you can deploy your model into different execution provider efficiently in the optimized way. So that's the actual workflow. So we have a question. Let me be a little provocative, and let me ask you some question. So we standardize the file format with ONNX. We also standardize the runtime with ONNX runtime, which these two steps are a huge major achievement. But let's be honest, the development experience is still over the place. Everyone builds his model in his way. Everyone develops his pipeline, wrapper, script. And there is no place for the development experience. So we think about it a lot. And another question came to us. If ONNX is a universal graph format, where is its native framework? So we look at it. We didn't find it, so we build it. So let me introduce to you SOTA, the first AI native framework entirely developed around ONNX and ONNX runtime. So how it works? We have two major technologies building on this framework, on this SOTA. The first technology is the full integration of ONNX on ONNX runtime. What we call full integration means no conversion. It's native. It's totally native, and the full orchestration of ONNX runtime. The second thing is we integrate it. Instead of using Python, we prefer to use LabVIEW. LabVIEW as a graphical data flow programming language, as it's more accessible for everyone and well spread around the laboratory, industry, and academia. LabVIEW is a graphical data flow programming language that enables users to create programs by manipulating visual elements rather than writing text-based code. Unlike traditional flowcharts, which only represent logical flow of processes, LabVIEW is specifically designed for developing and executing complex systems, and that makes it an ideal foundation for SOTA. So what we propose today is a full orchestration of ONNX runtime with LabVIEW. And unlike ONNX runtime, which allow inference and limited training, SOTA technology unlock full orchestration and parameterization of any training graph, including dynamic injection of arbitrary loss. So let me show you how it works. So this is the orchestration you will see. So this is LabVIEW diagram. So you have a palette. So you can drag and drop directly your element on the diagram. So this is how we directly define a model. So we can import, modify, and do what we want with ONNX. And with ONNX runtime, as it's a graphical data flow programming language, we can orchestrate it as what we want. So we can do any architectures. An example of this orchestration is YOLO. We are the first company in the world able to do totally graph, no ultralytic code. We can directly train a YOLO 11, for example. This is a computer vision field. We also can do, for example, a UNet for medical industry. So this is a segmentation model. So, and what is good with LabVIEW is you can do directly monitoring, but also we can do reinforcement learning. So this is a lunar lander, directly orchestrated by LabVIEW, because we make a fusion between ONNX graph and software architecture. So you can do what you want. There is no limitation, to be simple. And we use only ONNX on ONNX runtime. Another example of orchestration with LabVIEW is reinforcement learning of Formula G. It's like a car game. So we can do what we want. So this is a full orchestration. So this is the power of SOTA. And now another question came to us. If ONNX is the best system file for defining graph, and if ONNX runtime is the best general execution provider, we can see it like this, and with optimized way to directly execute any graph, why we don't push far beyond? So another question came to us. If ONNX is a universal graph format, where is the universal graph editor? Of course, we speak about artificial intelligence, but we can go far beyond. So we look at it, we look for it, we didn't find it, so we build it. So we propose a graph framework with a graph editor, making you the possibility to import any ONNX file, create, edit, do whatever you want, and also orchestrate it directly in ONNX runtime, so for the training part and also for inference, from IoT to cloud, so you can do what you want. So, demonstration. It's better. So, as LabVIEW is very accessible, everyone understood how it works. It's very simple to understood. So, we start by defining any operation. So this is a beta version of accelerators, but it will be available in 2 weeks. And data input, execution, and as you can see, it executes like data workflow. So LabVIEW is very powerful for this, and is totally adapted for this kind of technology. So we can do, for example, hardware acceleration in test and measurement. Why not? Let's do it. We also can do computer vision. Let's do it. Why not? So we can take any functionalities from computer vision, and we can traduce it directly in graph technology. And if you have a benchmark, our benchmark from OpenCV to ONNX runtime, we are about 40% more speed. So this technology is a killer. So that's what we propose. But I was not totally honest with you when I came here, because I say, okay, the name of the presentation is AI framework, SOTA AI framework. SOTA is not an AI framework. It's not also a graph framework. SOTA is a complete suite. SOTA is like Microsoft Office suite, but for artificial intelligence and graph technology. SOTA is a unified suite of easy-to-use, interoperable tools, each more innovative than the last, designed for engineers, researchers, and academics. And we cover all the spectrum: deep learning, computer vision, accelerator, generative AI. So accelerator is the generalization of graph. So we generalize graph for all the operation. So what we speak today about all the presentation, we will integrate all these new technologies. So generative AI was a good example, the presentation before me. It's a good news. We will integrate all the transformer library, and we will directly use it as in GenAI. GenAI now is working with Llama CPP, But step by step, we will make a replacement of Llama CPP directly in ONNX ecosystem. Okay, so SOTA is here. SOTA is just the distribution, but we have deep learning toolkit, computer vision toolkit, graph computing toolkit, generative AI, and some tools. Well, okay. So the spectra of what we cover a large landscape. So for Keras, TensorFlow, PyTorch, why we put Keras, TensorFlow, PyTorch? Because a node, or if you want to speak to the engineers, you use Keras, so you will use layer. Layer is just a combination of node. And if you want to speak to the researchers, you will use PyTorch or TensorFlow. You will speak with node. We speak both language, no problem. OpenCV for the computer vision, RoboFlow because we are now working on the annotation tool. And all of these technologies are based on ONNX runtime, exclusively and natively. Okay, so in review, we start with ONNX system file, the best one. We can define everything with ONNX system file, any graph. Okay. So ONNX runtime came for inference on limited training, but working with the ONNX system file. Then Graiphic came, and we decided to orchestrate entirely file system, ONNX system, and entirely runtime with a full training totally unlocked. So we do what we want. And also inference, because it's already working. And now we decided to make this in generalization as a graph. So we speak graph. So all the operation is possible with ONNX and ONNX runtime. So normally we have a little time if you have a question.